Okay, so next we're going to go the opposite way, and we're going to convert from radians into degrees. And again, today, doing all the conversions today is just getting comfortable with this unit of measurement, because it's what we're going to be using this whole unit. So I'll give you a second to copy those down if you want, or you can copy along, or the supply teacher can pause the video if we need to. But we should have enough time to at least get started. So again, what we need to remember when we're going from radians into degrees is this. Pi is equal to 180. So wherever we see a pi, we know that we're talking about 180 degrees. So equals pi. And so what we're going to do here is, if it's pi over 3, then it's 180 over 3. Right? And what is 180 divided by 3? 60. Yeah. And again, if we just stop and think about it, pi is 180, and this is saying 1/3 of pi. So it's obviously something smaller, and we're going to break it up into 3 chunks, and it would be 60 each, right? So 180 divided by 3 is 60. And again, you're going to get so comfortable with that when I say what's 60 degrees, you're going to say pi over 3. Okay? Now we can get more complicated ones, stuff like 2 pi over 180, where it might not be as obvious in our head, like 2/5 of pi, but that's okay. We can just do the math. Pi is 180, so we replace pi with 180 when we're doing the conversion over 5. So now it's 2 times 180 divided by 5. And I think off the top of my head, that's 72 degrees. You could also do 2 divided by 5 and get 2/5, and then times 180, it would get you 72 as well. For C, I wanted us to stop and maybe do a prediction. Okay? So let's look at 9 pi over 4. So for starters, do you think it's going to be more or less than 180? More, because we have a bigger fraction, right? It's not like pi over 4, it's 9 pi over 4. Okay? Now, my next question is, do you think it's actually going to be more than 360 degrees? How come? Okay, so Jake is saying 9 times 180 is going to be a really big number, and then divided by 4, it's probably going to be bigger than 360. So that's one way of thinking about it. What else do you think? Give me another reason why you think it might be more than 360, Bobby. Okay, so Bobby said the numerator is more than twice as big as the denominator, which is really interesting. So let's just do the math first and see if we're right. So it's 9 times 180 over 4. So like Jake said, that's a pretty big number divided by 4. And I think we get 405? 405 degrees. So we wouldn't have never thought of 405 degrees as a corner in a triangle, right? That's not, you can't think of that. But you can think of 405 degrees as more than one rotation. So you're going around the circle, 360 degrees, and then you keep going a little bit more, right? And that is a possible thing. So this is another reason why we use radians instead of degrees, because we can start talking about rotations. And that's going to be part of the math that we're going to look at later, is rotations. And I like what Bobby said about it being more than twice the denominator. So if we're talking in quarters, how far is pi? So if we're talking in quarters, would you agree that 4 pi over 4 is the same as pi, right? Because that's 4 quarters. It is 1 pi. Okay, so pi gets you halfway around the circle. What would get you all the way around the circle if we're talking quarters? Yeah, you'd need another 4 quarters, and that would be 8 pi, right? So 8 pi over 4 is 2 pi, do you agree? Right? So if you had 8 quarters, we go all the way around a full rotation. Now the one confusing part is, unfortunately, like pi is only half a circle. So we have to think of quarters of half a circle, not the whole circle. So that's a little bit confusing. But once, I mean, we know that a whole circle is 2 pi, okay? And so if we're talking quarters, if you have 4 quarters, you're halfway through the circle at 180, or pi. And if you have 8 quarters, then you've gone all the way around because it's 2 pi. And our example here is 9 quarters, right? So obviously that's more than 8 quarters. It's a little bit more than 8 quarters. It's actually pi over 4 more. So it's 45 degrees more than 360, which is 405. Okay, we're going to talk more about that, but that's the kind of thinking that I want you to think about. I don't want you to memorize this. You really got to understand it. We'll do more of that tomorrow. But the fact that we're starting to predict it is good. Okay, D, negative 4 pi over 3. So for starters, we remember the negative means we're going the opposite direction. Do you think it's going to be more or less than 180 degrees in the opposite direction? More, that's right, because 180 degrees would be, since we're talking thirds, it would be 3 of them. And here we have 4. So we're going in the negative direction more than 180 degrees. For the math, it's really easy. We still just go 4 times 180, well, negative 4 times 180 over 3. So you go 4 times 180, get a number, divide by 3, and we get negative 240 degrees. Okay. And as we predicted, that is more than 180 degrees in the opposite direction. And then the very, very few times we instead of talking about radians with the pi reference, we just talk about the actual number. So remember, 2 pi is still a number. It's like 6.28. So this 4 radians would be something less than 2 pi. Every once in a while, we get out of these pi references and we just talk about the actual number 4. And this would be an example here. This is where we would go back and say, oh, remember this little thing right here? 1 radian equals pi over 180. Oh, is it 180 over pi? Thank you. So 1 rad, so if 1 rad equals 180 over pi, then 4 radians would just be 4 times that number. So it'll be 4 times 180 over pi. And go to your calculator, 4 times 180 divided by pi, and we get what? Sorry? Did people get that? 229.18, so can I say 2? Would that be okay? And that number makes sense? Sure, right? We know that a full rotation is 2 pi, which is like 6.28, right? Double 3.14. This is less than that, so it's less than 360 degrees. We don't see that too often, but we do got to remember where it is. Okay? The last thing I'm going to point out is that you actually have this unit of measurement on your calculator. So you know how when you do angles in trigonometry, you got to make sure it's in DEG, degrees, and not RAD, rad? Well, the rad is radians, okay? We won't use that calculator measurement too often. Okay, we will later on when we start talking about word problems and things like that. We'll convert our calculators to radians. But for what we're doing, we still want it to be in degrees because we're converting from degrees to radians. So I wouldn't want you to use the pi button in the radian thing. Right now, we want the pi to be a reference in degrees. So keep your calculator in degrees, but later on, you'll recognize that sometimes we might need to change it to radians and then change it back to degrees. Okay, so there's where your calculator comes into this. So that should get you started. And remember, today is just about practicing converting from degrees to radians and getting comfortable with those radian measurements. So you're going to try a few of these questions. Again, as always, try a few. Maybe A and C from each one would be sufficient. If you really want to learn more about radians, you can do number 5 and 6, where it talks about the definition of radians and radius. But the important ones are the conversion from degrees to radians and radians into degrees. And now we have a message from our president.
This is David Willman, and I approve this message.